Imagine you're a social psychologist conducting a survey where participants are asked for general feedback. You've helpfully provided an open ended text box for them to enter their contact details if they wish to be contacted further. While many respondents provided their phone numbers, they didn't use any consistent format. So some people, for example, may have written, call me at 555 1234, or you can reach me at this phone number, or even some international format that you didn't recognize. This means that phone numbers are buried within longer responses, and it's going to be a nightmare to go through every response manually to pull them out. This is where something like regular expressions could be very useful. A regular expression can scan all the responses, extract just phone numbers, and ignore irrelevant texts. You'd be able to capture all the phone numbers from various formats in a matter of seconds, and this can allow you to easily organize your dataset. Regular expressions, or regexes for short, are a powerful tool for working with text. Essentially, regexes allow you to define specific patterns that can be used to match, search, and manipulate text in ways that would be time consuming or complicated to do manually. Think of it like creating a custom search tool that understands not just exact words or phrases, but patterns, like phone numbers, email addresses, dates, or any other structure you might find in a block of text. For example, if you wanted to find all phone numbers in a document, regex will look for patterns like digits grouped together, dashes or spaces in between, and even country codes without you having to look at each one individually. The terminology can be a bit hard to understand if you're not familiar with computer science theory, but regular expressions are pretty simple once you understand them. They seem complicated at first, but once you just understand the basic structure, you can use it to easily clean up data, extract specific information, or even replace text, all in seconds, saving you loads of time. Let's cover a few of the basic operators that you can use to write regular expressions. So before we walk through an example, let's quickly walk through some of the basic operators that you can use to write a regular expression. The dot matches any single character except for a new line. So for example, if you use the pattern A dot B, it will match any string that has an A followed by any character followed by a B. This means that it will match strings like ACB, A1B, A space B, and so on. Next, let's look at the caret and the dollar sign operators. These are used for matching the beginning and the end of a string. The caret is used to indicate the start of a string. For example, caret A will match any string that starts with the letter A. So apple will match, but banana will not. The dollar sign is used to indicate the end of a string. So B dollar sign will match any string that ends with the letter B. For example, club will match, but bake will not. You can even combine those two. So for example, caret A dot B dollar sign will match any string that starts with A, has any character in the middle, and ends with B. The asterisk means 0 or more of the preceding character or group. So A asterisk B will match any string that contains B and has 0 or more A's before it. So for example, it will match B, AB, AAAB, AAAAB, and so on. The plus sign is similar to the asterisk, but it means 1 or more instead of 0 or more of the preceding character or group. So for example, A plus B will match any string that has at least one A followed by a B. It will match AB, AAAB, but not just B by itself. Next, we have the question mark. This operator makes the preceding group or character optional, so it matches 0 or 1 of the preceding element. For example, color will match both color and color. The U is optional. Square brackets define a character class, which means you're specifying a set of characters that you want to match. So for example, brackets AEIOU will match any vowel in the string. You can also specify a range of characters inside the brackets. So for example, bracket 0-9 matches any digit, and bracket A to Z matches any lowercase letter. Now, when a caret appears at the start of a character class, so inside a set of brackets, it negates the class. That means it will match any character except those in the brackets. Now, we keep talking about either a character or a group. What's a group? Groups are defined with parentheses. Parentheses are used for grouping parts of your regex together, and that allows you to apply operators like asterisk, plus, or question mark to an entire group and not just a single character. So for example, parentheses ABC plus will match one or more repetitions of the entire sequence ABC. So it will match ABC, 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 and so on. The pipe is used for OR operations. That means it will match one expression or another. So for example, cat or dog will match either cat or dog. So it will match cat in the cat is cute, and then dog in I have a dog. Finally, let's talk about the escape character, or the backslash. In regexes, certain characters like the dot, parentheses, and the asterisk have special meanings. Now, what if you want to match one of those characters literally? You want to literally find a parenthesis. Then you need to escape it with a backslash. So for example, to match a literal dot, you would write backslash dot. This tells the regex engine to match an actual dot and not just any character. Character classes can be very useful because they define a range of characters. The lowercase letter matches a range of characters, and the uppercase letter matches any character not in that range. \d matches any digit, and then \D matches any non-digit. \W matches any word character, so that is an alphanumeric character or an underscore, and \W matches any non-word character. \S matches any white space character, so those are characters that you cannot see, like spaces, tabs, and line breaks, and \S matches any non-white space character. \B matches a word boundary, so that's the boundary between a word and a non-word, and then \B matches a non-word boundary. Lastly, you can use curly braces to define how many repetitions of a character or class are allowed. So let's go through 2 examples together so we can get an idea of how regexes work in real life. The first one is let's try to write a regex that matches a hashtag, like you might see on Twitter. This is basically a hashtag sign followed by a group of text with no space, so an example could be #SoHappy. You can take a minute to pause the video and try to work it out on your own. Now, one simple solution to this could be a hashtag sign and then a \W, which means any word character, so that's any alphanumeric character or an underscore, and then plus. And the plus tells us that we can have one or more of those characters. That means that the first time the regex sees a space or a period or a question mark, it's going to stop there. We can see in the example below that this regex matches hashtags pretty well. The second example, which is slightly more complicated, is to write a regex that matches email addresses. So this we could define as a group of alphanumeric text, followed by an @ symbol, followed by another group of text, followed by a period, and then followed by another group of text. So an example would be me@example.com. Now, one solution to this could be \B, which defines a boundary character. So this tells the regex that it should be a break between the word before and this word. \W+, which allows us to define a group of text, an @sign, another \W+, which defines any group of text as we defined before, and then a \period, which matches a literal period, another group of text, and then another \B to define the end of the regex. Now, I want to quickly talk about capture groups. Capture groups save parts of the text so that you can use them later, and this can be very useful when you're writing a regex of something to replace. So you want to say, take the text that matches this pattern and then replace it with something else. Every capture group or set of parentheses that you use can be referenced by a number starting from 1. So the first capture group is $1, the second one is $2, etc. So here's an example of capture groups. Imagine that you have the text John Smith and the regex is parentheses \W plus and parentheses and then a space and then parentheses \W plus and then a space. So this is effectively looking for a word, a space, and then a word. Now, if the regex finds this pattern, then the first word is going to become $1 or the first capture group. The space is not going to be assigned to any capture group because it's not in a parentheses. And then the second set of parentheses, which is the second capture group, will become $2. Now, if I wanted to replace it by putting the last name first, I could say that the replacement pattern is $2, $1, and that will replace it with John Smith. You could imagine why this would be really useful. For example, if you had a spreadsheet with 100,000 rows and you wanted to change the rows to be, instead of first name, comma, first. Now, where can you actually use regular expressions? Let's talk about 3 places where regular expressions can be useful: on the command line, in code, and in your IDE and other tools. So on the command line, regular expressions can be incredibly useful, especially when working with large datasets and text files. For example, in Unix systems, you can use tools like grep, sed, and awk, which support regular expressions to search, filter, and manipulate text effectively. You can also use regular expressions directly in code. So for example, in Python has built-in support for regular expressions with the re module. So here's how you could use it in Python. So for example, if you wanted to find phone numbers in a string, you could use re.findAll to match a pattern against text. And one of the advantages that using regular expressions in code over string methods is that it's actually much, much faster. And that can be useful if you're going through, let's say, millions of lines trying to find something. Here's another example where you can replace text. So for example, let's say I wanted to redact text. So I have people's real emails all over a text document and I want to replace it with just the word email and redact it. So here's how we could do it with re.sub, which is short for substitute. So in this example, we see that all the emails are now replaced with just the words email. Now, another place where it can be really useful to use regular expressions are tools with find and replace functionality like your IDE or Google Docs. So let's say, for example, you have dates in the format date, month, year with dashes, and you want to convert them into the year, month, date format. So here we can see that you can just type in the find pattern. So this is a regex that will capture the date, month, year format, and then we can replace it with $3, which refers to the year capture group or the third capture group that we had in the previous regex, and then $2, which is the second, and then $1, which is the first capture group. So after this replacement, we see that the date, month, year formats have all been changed to year, month, date formats. You can also see in this screenshot that the same functionality is available in Google Sheets, and we can do the same thing to turn dates from year, month, date into month, date, year format. Now, I want to show you a website that I love to use with regex. This is Regex 101, and it is really, really fantastic. It allows you to enter a regex, immediately see matches, you can list matches, or you can even replace them with something else. It's super useful for even just everyday life. Now, let's talk a little bit about writing regexes because as you can see, regex get very complicated very fast. So, two very useful resources that you can use when it comes to writing regexes are the internet in general and then LLMs like ChatGPT. So, regexes have been around for a long time, and you can often find on the internet regexes for specialized use cases like email addresses or phone numbers in any format for any country. And those are very useful because you know that people have used them and they will match anything you need. Now, LLMs are another great tool for generating regular expressions. So you can just tell the LLM the pattern you want to match, and then the LLM can generate the regex for you. Remember to verify it with a tool like Regex 101 because LLMs are known for hallucinating. So I hope that after watching this video, you feel more confident in using regular expressions. Remember, they are incredibly powerful, even though they're a bit tricky at first, and the key is to practice and experiment until they start to make sense. If you enjoyed this video, be sure to hit the like button and don't forget to subscribe for more content. Next, we're going to look at a couple of tips for how you can really get the most out of your IDE and work much faster in it.